Okay, so today we're going to start chapter 10. It's some right triangle trigonometry, which you guys did some in geometry. So it should be a little bit of a review for you. Okay, again, it's right triangles we're talking about. Okay, not wrong triangles. All right, so you guys know what a right triangle looks like. It's got one 90-degree angle. What about the other two angles? What will they add up to? 90, right? Because all three angles of a triangle add up to 180, right? So this little blue symbol is called theta. It's a Greek letter. So if theta is there, that means straight across from it is called the opposite side. And the one that it's connected to is called the adjacent side. The side that's always opposite the right angle is called the hypotenuse. That's all review for you guys, right? No? First time you've ever seen this. Okay? So, again, depends where theta is about these. Opposite side isn't always the one that's going up and down. If theta's up here, then this is the opposite side, and that's the adjacent side. You understand? So it depends where that is, the angle you're looking at. But this is always the hypotenuse. It will always be the longest side, too, in a right triangle, because the biggest angle will always be the 90-degree angle, the right angle. Okay? So there are what we call trig ratios, trig functions, that are sine, cosine, and tangent, and then cosecant, secant, and cotangent. Sine and cosecant are reciprocals. We will write these as fractions. Cosine and secant are reciprocals. Tangent and cotangent are also reciprocals. So once you have one of them, you already got the other one basically by flipping. Okay? All right. So the sine is the opposite side, whatever that number is, over the hypotenuse, so that fraction. So let's say the opposite side is 3 and the hypotenuse is 5, so it'd be 3/5. So then the cosecant, we use CSC. These are the abbreviations we use. This would have been 5/3, and you just flip it. Okay? Cosine is adjacent side, whatever its length is, over hypotenuse. Okay? The secant, you just flip that fraction. Cotangent is the opposite side value over the adjacent side value. Cotangent, you just flip it, adjacent side over opposite. Okay? So the way I've always taught my kids, or I was taught, and I do the same thing, is remember the mathematical Indian chief, SOHCAHTOA. S for sine, O for opposite, H for hypotenuse. C for cosine, A for adjacent, H for hypotenuse. T for tangent, O for opposite, A for adjacent. So SOHCAHTOA is what I always say. Help you remember. Okay? Again, you can write the cosecant, since it's the reciprocal of the sine, it's 1 over the sine. The secant's 1 over the cosine. Cotangent's 1 over the tangent. In your calculator, you have those three buttons, sine, cosine, and tangent. Okay, if you look here, right in the middle here, there's sine, cosine, and tangent. Okay, you don't have cosecant, secant, or cotangent. All right. Now, what you want to do is hit your mode button and make sure degree mode is highlighted. There's things called radians and there's things called degrees in trig. So when you do some problems, if you have to use a calculator, which you will on a couple problems, you want to make sure it's in degree mode. So the mode button here is right next to second. So hit mode and you'll see this screen like I have, and make sure that degree is highlighted so that when you do a problem, you'll be in the right mode. Anybody having issues with that? Okay. So let's look at some examples of what we're doing. All right. Evaluate the 6 trig functions of angle theta. Okay. So I need to find sine, cosine, tangent, cosecant, secant, and cotangent. That's what they're asking us to find, those 6 fractions. Before I can do that, I need to find the length of this side. Which one is this? Adjacent, opposite, or hypotenuse? That's hypotenuse, right? Everybody understand that, right? Because the right angle's here, the one opposite the right angle, the longest one is always a hypotenuse. Okay? Now, since it's a right triangle, there's a thing called the Pythagorean theorem. Anybody know what that is? I heard, is that you, Cohen, saying that? Yeah. A squared plus B squared equals C squared. C is always the hypotenuse. A and B, doesn't matter which one you make. We call those the legs. So if you're talking about right triangles, the 5 and the 12 are the legs, and that long side there is the hypotenuse. Okay? So these are both the legs. So I can go 5 squared plus 12 squared equals C squared, which is 25 plus 144, which is 169. And then what do I got to do to figure out the length of that side? C squared is 169. So what is C? What do I have to do? Square root, right? And that comes out to 13. So you have to do that first so you know all 3 sides. And again, we're used to doing plus or minus, but we're talking about lengths of sides, so it's going to be the plus part. It's not going to worry about the minus part, okay? So this is 13. All right. Now I can answer the question. Sine of theta. Here's theta. Opposite. 5 or 12 or 13? 12. Hypotenuse. 13. So the cosecant is its reciprocal. So we got 2 of the 6 already. Cosine. Adjacent. 5 over hypotenuse 13. Remember, so now we're going to run out of room for toe. We'll have to go down to it. All right. But the secant, so don't get these mixed up. Sine, cosecant. Cosine, secant. So CS, SC. Don't do SS and CC. Okay? That's what some kids do. All right. So this is, oops, theta, sorry. 13/5. Okay. Tangent. Let's see if I can squeeze it. I can't. Tangent. TOA. Here's theta. Opposite 12 over adjacent 5. Cotangent. Flip that. 5 over 12. So there's our 6 answers. I think you're right. You know, minus a negative is what? Questions? Pretty easy, I think. So if you only have 2 sides of the right triangle, you need to use Pythagorean for the 3rd side. Okay? They don't always give you the 2 legs. Sometimes they give you a leg and the hypotenuse. So make sure you put the C value, hypotenuse value, if they already give it to you, in the right spot. Okay? Is there another one here? No, good. That's what they did here. right? 18 is the hypotenuse. 18 is the C. Do you see that? All right, I'll just call this side A. So A squared plus 10 squared equals 18 squared. What is that? 324, I think. Somebody check me. I think it is. So 324 was right. Somebody said yes. Who is that? Lucas? Cohen, thanks for checking. Okay. Now, that's not a perfect square. All right. Square root of 224 is a decimal. Okay. We don't want to use a decimal in a fraction. So we're going to put it in simplest radical form. So we have to do a factor tree. All right. All right, 2 plus 2 is 4 plus 4 is 8. That means 9 won't go into it. So it ends in a 4, 224, I think 4 will go into that. Let's see. 4 goes into 25 times. And 4 goes into 24 6 times. Checking. Is that 4 times 56? Okay. And then I'm going to keep that. Because it's a what? Perfect square, right? I think 4 goes into 56. Is it 14? Okay, thanks. So, for the square root of 4, I can pull what number out? For this square root of 4, I can pull what number out? What I do with those two 2's? Multiply, right? So this is going to be 4 radical 14. Oops. In radical form. So don't put the decimal. You hear me? Don't put the decimal. We want it in a fraction form. You don't mix fractions and decimals together, right? So we're going to put it in radical form. So then we're just going to do all our stuff. Sine, cosecant, cosine, and secant, and tangent, and cotangent. Now, this is going to be a little more work because of the radical, and I'll show you why. All right, so here's theta. Sine is opposite over, let's do this first. Here's another trick I do. I'll show it to you now. What number goes into all three of these? 2, right? So instead of reducing later, let's just reduce it now, okay? You can't take a 2 out of the 14. You can't do it mess with under the radical, but you can mess with the stuff out front of it, okay? So I'm going to turn this into 2 radical 14. I'm going to turn this into 9. And I'm going to turn this into 5. I just divided everything by 2. You okay with that? So now as I write these fractions, they're basically going to be reduced for me already. I'm trying to do it ahead of time. All right, so if you notice a 2 or 3 or 4 goes into the 3 numbers you have for your sides, I would reduce them there before you start. Does that make sense? Okay, so sine again, opposite, 2 radical 14 over hypotenuse 9. So what's cosecant going?
Would you take points off
if you didn't reduce it? Yeah. Yes, I would. Always write fractions in those terms, right? Like one of our answers yesterday was a fraction on the quiz, and you guys had the right fraction, but you needed to reduce it to those terms. So I marked the point off. You had the right fraction, but 2 went into both of the numbers, so you didn't reduce it. Okay? So that kind of thing we always do. All right, now what's the cosecant going to be? What do I do with this fraction? I flip it, right? But what's it look like then? It's going to be 9 over 2 radical 14. Am I allowed to leave a fraction with a radical in the denominator? No. So I have to do this. So that's what I'm saying. When you got the radicals, sometimes there's more work. This is what I'm talking about. We have to do some rationalizing. All right, so what happens with these two 14s when I multiply? What number do I get? No. When I multiply those two 14s.
14.
Yeah, 14, right? You guys, that's why we do that. So this comes out to 14. But don't forget the 2's there. What's 14 times 2? 28. So this is the fraction we need to write for cosecant. Okay? This is the proper answer. Okay? So 9 radical 14 over 28. Cosine is adjacent 5 over hypotenuse 9. So this is nice. We just go 9 over 5. Okay? Tangent, here's theta, opposite TOA. I didn't write TOA, but TOA over adjacent 5. Right? So 2 radical 14 over 5. So this is going to be like this one. Okay? So 5 over 2 radical 14, I'm going to be doing this. I got to do the radical 14 again. And that's 28 again. Okay? So there's our 6 trig ratios, trig functions. So they don't always draw the right triangle like this. See, it's in a different spot. It's not like on the ground. It's up here in the air, right? So remember, that's the hypotenuse, always the one opposite. Okay? Wherever they put theta then, straight across is opposite. The other one is adjacent then. Questions? So that's one of the things you're doing. Okay? Sometimes this is the same thing, but they don't give you the picture. You have to draw the picture. In a right triangle, theta is an acute angle. Sine of theta is 4/7. So you have to draw the picture. Okay? So we're going to draw the picture of our right triangle. Come on. Well, that didn't do any good. Well, we just won't do that then. I'll just draw it. I thought it would draw a nice one for me. Okay, I'm just going to say theta's here. You can put it either one, doesn't matter. Okay, I just like to put it down there. Okay, so the sine, which side does the 4 represent? Indian chief, so what's the 4 represent? Opposite, so there's the 4. What's the 7 represent? Hypotenuse, so that's the 7. So it's the same type of problem, it's giving you the information differently. Does that make sense? Everything else is the same. How am I going to find the missing side? Pythagorean, right? You know, you can make this one b if you want this time. But you're going to go 4 squared plus b squared equals 7 squared. And everything else is the same. Questions? Does that make sense? So it's the same type of problem. They just ask it in a different way. You have to draw the picture first from that fraction. That fraction gives you enough information to draw the picture. Any questions on that? I don't need to do the rest of it, do I? You guys understand what to do from there, right? Once we figure out b, we just do all our fractions, right? You okay? All right, let's move on. Here's the same type. All right. So we'll just do it. I'll just draw it real quick. Again, I always just draw it looking like this. All right. Cosine is adjacent over hypotenuse. So that's what I start out with. Then I got to find that missing side and go from there. Okay? Find the other 5. They give you one of them, right? All right. All right. Special right triangles. Whenever you're learning trig, if you have these 2 things memorized, your trig life is so much easier. Right, John? So memorize these 2 things that I'm going to show you right now. Okay? And you did this last year because I'm watching Miss Ostich in the other room later in the day. She teaches geometry, and this is exactly what they have a quiz over today. Is this right here. Okay? So, if these 2 angles are the same, what do you know about the 2 sides? They're the same. You learned that last year, right? It's called an isosceles triangle, right? This is an isosceles right triangle. But we call it a 45, 45, 90 in trig. That means whatever that number is, that number is. So that's a 2, that's a 2. That's a 10, that's a 10. Right? It's basically half a square, isn't it? You know what that is? Okay. Hypotenuse, you could, if you want, do Pythagorean to figure that out, but this is what it always equals. Whatever this side is, times the square root of 2, always. When you do Pythagorean, no matter what these numbers are, it's going to be that number times the square root of 2. So just memorize it. So if that's a 3, that's a 3, that's a 3 radical 2. Okay? If that's a 5, that's a 5, that's a 5 radical 2. What if that's a 20? How do I get back this way? Divide by radical 2. Very good. So if you know these 2, you multiply by radical 2 to get there. If you know this one, you divide by radical 2 to get here. Okay? And you can figure it out. So sometimes they'll give you this one or this one and tell you to finish it. Sometimes they'll give you that one, and you got to figure these 2 out. Once you figure one of them, you got the other one, right? That's always true. 30, 60, 90. Okay. We call this one the short leg. So whatever, that's a 2. The hypotenuse is always twice as long. So what would it be? If that's a 2, that would be a 4. If that's a 10, that's a 20. So if that's x, this is always twice as long, 2x. Always in a 30, 60, 90. We call that the short leg because it's opposite to 30, the smallest angle. So that side's shorter. That's always going to be true. The 60 is the next longest. So short leg, we call this long leg. All right? It will always be that number times the square root of 3. Always. All right? So if that's a 5, that's a 10, and that's 5 radical 3. If that's a 12, that's 24, and that's 12 radical 3. If this is 50, what's this? 25. What's this? 25 radical 3. If this is an 8, what's that? 4, and that's 4 radical 3. What if this is 6 here? How do I get to there? Divide by radical 3. Okay? So sometimes they'll give you the long leg. So to get to the short leg, you got to divide by radical 3, which means you got to multiply top and bottom by radical 3. And then to get to here, you double that number. You just double the number in front of the radical. Everything else stays the same. Okay? So that's always true. So memorize those 2 things, you got it. a lot of times I'll just make these ones, I'll just go 1 to remember 1, and that's radical 2. I usually go 1, 2, radical 3. That's how I think about it if I have to draw one to do it. All right, Brennan? All right, so let's look at 30. Okay? Which one's this? Is this the short leg, the long leg, or the hypotenuse? Hypotenuse. What's the relationship? How do I get to there? Divide by 2. So I'm going this way, right? First. So this becomes 4, but what's this going to be, the answer they're looking for? 4 radical 3. You don't have to do Pythagorean or anything. You just know it because you've memorized it. It's really easy. Okay? 45, 45. Okay? This is the hypotenuse. So I have to divide by what to get there? Not 2, but radical 2. So then I have to rationalize it. What's the bottom become? 2. But what can I do there with 6 and 2? I can make that a 3. You see that? So that's what X is. What would this side be? Same thing, right? 45, 45. The 2 legs are equal. Right? But they gave us a hypotenuse, so we had to divide by radical 2 to get there. If they gave us the 6 here, and we had to find the hypotenuse, we just go 6 radical 2, we'd be done. Okay? See. Again, you memorize those 2 triangles, your trig life is so much easier. 45, 45. Here, this one's real easy. I just said this, actually. Anybody? Thank you. Okay? You don't have to do Pythagorean to figure it out. Because you've memorized it. You know it. All right. Finding all unknown side lengths and angle measures of a triangle is called solving the triangle. So if you're asked to solve a triangle, you need to know all 3 angle measures, which add up to what again? 180. You need to find all 3 sides. Okay? You know the Pythagorean theorem will work because we're talking about right triangles. Okay? We already talked about putting it in degree mode, right? All right, so here we're going to use our calculator. All right? So the first thing I do, if I know 2 of the angles, I always find the 3rd angle. Okay? So angle B is 90 plus 28, which is what? 118. And then 180 minus 118, which is what? 62. Or, if that's 90, you know those 2 add up to what? 90. So you could just do 90 minus 28. That's probably easier, right? I should have did that. That's still 62, right? Good? Okay. So that's the first thing I do is I answer that. Okay? Since they gave me 28, I'm going to use this side. I'm going to look for A. So 28, A is opposite, and B is adjacent, right? So which one uses opposite and adjacent? That one, right? Remember, SOHCAHTOA, right? So we use tangent. So here's a little problem we have to do to figure out A. Tangent of 28 degrees equals A divided by 15. Opposite over adjacent. Now, how do I write that as a fraction? Put it over 1. So when we had one fraction equals another fraction on the quiz yesterday, what did we do? Cross multiply, right? That's what I would solve this. Kids do better if they just cross multiply. So 1 times a is a, and tangent 28 times 15 will be our answer. Now, when you hit tangent, you'll have this left parenthesis. Go ahead and close it off. And I don't think you even have to write times. I think I'll just do that, all right? But you got to be in degree mode if it'll show up. There we go. So I'm going to go tangent, button right there, 28, and then 15. And it says round to the nearest hundredth. So 7.98 to the nearest hundredth. Have I solved the triangle? Do I know all 3 sides and all 3 angles? I got to find the hypotenuse. What are we going to do? A squared plus b squared, and then take the square root. You with me? So this is already in my calculator, right? So here's what I'm going to do. That's already my calculator. So I'm just going to go squared. So what it did, it just squared that answer. Plus 15 squared is 288.6. Is that the length of the hypotenuse? What do I have to do now? Square root that. You with me? So I'm going to go second square for square root, and you can go second negative sign. That's the answer we just had, that 288. So I don't have to type it all in. So second square for square root, second answer, hit enter. So it's 16.98, so 0.99, rounding to the hundredths. So we just solved that triangle. We found 3 missing pieces, right? That's what we had to find. Questions? Okay. Word problem. You're hiking near a canyon while standing at A. You measure an angle of 90 degrees between B and C. So see the little red box here? Tells you that's 90. All right. The measure of angle B is 76 degrees. And then C is way up here. The distance between A and B is about 2 miles. Tells us there 2 miles. About how wide is the canyon between A and C. So I'm looking for X there. Right? So they gave us this angle, 76. That's like the theta. What's X? Opposite, adjacent, or hypotenuse? Opposite. What's the 2? Adjacent. Which one has opposite and adjacent? TOA, tangent, right? So we're going to solve this, we're just going to go tangent, just like we did the last one. Tangent is 76 degrees equals X over 2. All right? We're going to cross multiply 1 times X, and tangent is 76 times 2. About time. What? It's about time. No need to be nervous. Maybe I did lock it. You were locked in, so you're good. Yeah, sure. All right. So, tangent button, 76. Close it up. 2. So 8 miles. Okay. So word problem though, but those usually give you the picture you need. Yeah. Nope. You're just in the wrong mode. You're in radian. Now do it. Hit second answer. Or second enter, sorry. Second enter. And then yeah. Okay. Make sure you're in degree mode. Okay. You've heard this before. There's a person standing on a rock looking up at the bird. Looking up is called the what? With a horizontal. Looking down at it on the water, angle of depression. Okay? So, it says a parasailer is attached to a boat with a rope that is 72 feet long. The angle of depression from the parasailer to the boat is 28 degrees. Estimate the parasailer's height above the boat. So, we'll just say this is a parachute, down to the boat. Okay? So, the angle of depression, said depression, right? That's here. So, what I like to do, I like to still go like this. These are parallels. So, what do you know about these two angles? They're the same. So, I just call, here's what I'm looking at. How long is my hypotenuse? How long is my hypotenuse? 72 feet, right? That's the rope that the parasailer is attached to the boat. Isn't that what it said? Okay, so what's this? What's X? What side? Opposite. What's the 72? Hypotenuse. Which one's opposite and hypotenuse? Sine, yeah. So we're going to go this one instead of tangent. We're going to go sine X. You can just put it over 1. X over 72. X times 1, cross multiplies. Sine is 28 times 72, and we'll get our answer. Sine's right here. 28, close it up. 72, enter. 33.8 feet up. Off the water. Questions? Simple, right? Gabby, you got it, or you just zoned out today? You got it? Good. I'm glad you're not zoned out. There's your homework. What's a little 3 after that mean? 3, 6, 9, 12, right?